Hello everyone, welcome to the series on chapter 1 of CBSE class 11th maths sets. In this video, we are going to discuss about the exercise 1.2 introduction. We'll learn about all the topics you need to learn to solve the problems from exercise 1.2. My name is Tejesh Kalki from 2Pi Academy. Now let's get started. So in this exercise, we are mainly going to discuss about some of the types of sets, namely empty sets, singleton set, finite and infinite sets, and finally equal sets. I'm sure you can guess what they are based on the names themselves. But first, let's see them one by one along with some examples for each of these, starting with empty sets. So what does the word empty mean? Empty means that there are no elements in something, right? If a box does not have anything, then it is said to be empty. So in the similar way, a set that does not contain any elements is known as an empty set. So if a set does not have any elements, it is an empty set. And you will denote a empty set by using curly braces with nothing in the inside or the Greek letter phi. So you know that you will represent sets by using curly braces, right? So if there is nothing in the inside, then it is an empty set because there are no elements inside that. And empty set also has two other names that are null set or void set. So both of these also refers to an empty set. Now let us see some examples of the empty sets. So first of all, we have capital A is the set of odd numbers divisible by 2. Now what are odd numbers? Odd numbers will be the numbers 1, 3, 5, 7 and so on, right? Now the definition of odd numbers is that they are not divisible by 2. So the set of odd numbers divisible by 2 will be empty, right? So you can denote that by empty curly braces. So this is the set capital A. It is an empty set because there cannot be any odd numbers that are divisible by 2. Or you can also denote this by the letter phi, as we have said before. And then the second one, the set of letters common in word and set. So word has the letters W, O, R, D and the set has the letters S, E and T. Are there any letters common in this? No, right? Every letter in the first word is not present in the second word. So therefore, capital B is also an empty set. So you will denote that by empty curly braces or you can use the Greek letter phi. This means that B is an empty set. And similarly, for set C, we have the set of all x such that x is a natural number and x is less than 3 and x is greater than 5. So if you take a number line like the following, here we have the number 3 and here we have 5, right? So since x is less than 3, it means that x will be in this part, whereas x is greater than 5 means that x will be in this part. So a same number can't be in both sides at the same time, right? It is not possible. So therefore, capital C is also an empty set, or you can denote that by the Greek letter phi. And finally, the set of dinosaurs that are alive. So sets need not be just numbers, letters, etc. It can also be animals or any objects, right? And we know that dinosaurs does not exist now, right? They are all dead. So therefore, the dinosaurs that are alive will also be an empty set. So this is what empty set mean. Now let's move on to the next topic, that is singleton set. So what does the word single mean? So if there is just one item, then it is said to be single, right? Single means that there is just one element. So the same is true in sets. A set that has exactly one element is known as a singleton set. So let us take some examples. The set of even prime numbers. What are the even prime numbers? We all know that the only even prime number is 2, right? So this is the set capital A. And as you can see, this has just one element. So this is a singleton set. And similarly, the set capital B is just the set of A, right? So clearly this also has one element. So this is also a singleton set. And finally, we have set C, which is the set of all x such that x is an integer and 1 less than x less than 3. So what are the numbers that are greater than 1 but less than 3? It is 2, right? Only integer that is greater than 1 and less than 3 is 2. So therefore capital C is just this set of 2. And clearly this also has one element. So therefore this is also a singleton set. So that is what Singleton set mean. Now let's move on to the next topic, that is finite and infinite sets. So here, what does the word finite mean? Finite means that there is a definite number of elements in the set, which means that you can get a fixed number of elements in the set. A set that is empty or contains definite number of elements is known as a finite set. So it can either be empty or it can have definite elements. Clearly, empty just means that there are zero elements, right? There is a definite number. So therefore, empty sets are also finite sets. So empty and singleton sets are finite sets, because as we have said, empty set has zero elements and singleton set has one element. So both of those are finite. But what about the infinite sets? If a set has an indefinite number of elements, then it is known as an infinite set, right? So if it is definite number of elements, then it is a finite set, and if it is indefinite number of elements, it is an infinite set. That is, you can't tell exactly how many elements are in the set. It is not fixed. So let's see some examples for these. First of all, we have capital A is the set of 1, 2, 3, 4, 5. Now in this, how many elements are there? There are clearly 5 elements in this, right? So since there are definite number of elements 5, then it is an finite set. And then the second one, capital B is the set of all x such that x is a day of the week. So let's first write this in the roster form. What are the days in the week? We first have Monday, and then Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Clearly there are 7 fixed elements in the set, right? There are definitely 7 days of a week. It does not change. So therefore this is also a finite set. And then the next one, capital C is equal to the set of natural numbers. So clearly natural numbers start with 1, 2, 3, and then it goes on until infinity, right? So it has infinite number of elements, which is clearly indefinite. There is no definite number of natural numbers. So therefore this is an infinite set. And then the set of rectangles that are squares. So now if you consider a rectangle, then there are clearly infinitely many number of rectangles, right? And out of them, how many will be squares? They will also be infinite, right? You can't get a definite number of squares that are possible. So therefore clearly this is a infinite set. So this is how you find whether a set is finite or infinite. Now let's see the last case. This is a bit of a twist problem, so let's see clearly. The set of humans living on earth. Now if you consider the number of human beings that are alive, it will be changing every time, but at any fixed point the number will be definite, right? So at any fixed point in time, the number of humans living on the earth is definite or fixed. Not everyone can count them, but there is a definite number. So therefore this is actually considered a finite set. So therefore you have to remember that it is definite number of elements. It doesn't mean that the number does not change. It means that at any fixed point the number will be definite. So therefore the set of humans living on earth is a finite set. So now let us move on to the last topic of this video, equal sets. So now what does the word equal mean? So if you have two numbers 1 and 2, clearly they are both not equal to each other, right? Because 1 and 2 are different numbers. Or if you have the numbers 1 and 1, they are both equal. But what does that mean in the context of sets? If two sets A and B have exactly same elements, then they are said to be equal. And we will write A is equal to B. So the notation is same as for numbers, but here the condition is that the two sets must have exactly same elements. What does that mean? It means that if you take two sets A and B, every element in set A will be in set B and every element of set B will be in set A. We'll see some clear examples later, but what if this is not the case? So otherwise the sets are said to be unequal, and you will write A is not equal to B. So if they have exactly same elements, they are equal, and you will write A is equal to B. And if they have different elements, then they are unequal, and you will write A is not equal to B. So consider the following examples. First we have set A with 4 elements and set B with another 4 elements. So in the set A there is an element 1 and the same element is in set B as well. And in the set A there is an element 2 and in set B also there is 2. And similarly in set A there is 3, and in set B also there is 3, and finally set A has 4 and set B also has 4. So they clearly have exactly same elements. So therefore you will write A is equal to B, or you can say A and B are equal sets. They are both equal sets, or you can write A is equal to B simply. And the second one, capital C is the set of A, E, I, O, U, and capital D is the set of vowels in English alphabet. They are both represented in different forms. First, we'll convert them to the same form. So first, we'll list the elements in set capital D. What are the vowels in English alphabet? Clearly, there are A, E, I, O, and U, right? These are the vowels in English alphabet. Now, if you notice, both the set C and D have exactly same elements, right? Both of them are A, E, I, O, and U. So therefore, capital C is equal to capital D. They are both equal sets. And now the final example. Capital E is the set of all x such that x is a natural number and x is less than 5. So we first have to list the natural numbers less than 5, which are clearly 1, 2, 3, and 4, right? 5 is not less than 5. So these are the elements in the set capital E. Whereas if you compare it with set F, here we have the element 1 and the same element is in F, and here we have the element 2 which is also in F, but here we have the element 3 which is not in F, and 4 is also not in F, and in the F there is an element 5 which is not in set E. So therefore both of these sets are not equal to each other. So therefore they are unequal, and you will write E is not equal to F. Thanks for watching the video. If you like the video, please subscribe to channel to not miss any future uploads. The problems from exercise 1.2 are solved in another video. The link is provided in the description.